Okay, shall we continue then with the tides? We looked at the lunar day, which is 50 minutes longer than the solar day because the Earth continues to move as the person is moving and trying to get under the moon next time, right? Gulab Singh got moved by 50 minutes. Right, so let's look at the relative tidal forcing by the sun and the moon here. So similar to lunar bulges, you expect that sun also will have a gravitational pull, and there will be residual force compared to the centripetal force of the wobbling around the barycenter and so on. The sun is much more massive, almost 27 million times the mass of the moon, but it's 390 times further away. So if you do 1 over r cubed, 390 cubed turns out to be about 59 million or so. So 27 million divided by 59 million actually gives you something like 0.46. So the solar tidal force on Earth is about 46% of the lunar tidal force. So it's less than 1/2 of the lunar tidal force. Okay, so despite being much more massive, sun is much further away, which makes the residual tidal force much smaller. But obviously it depends on the position. So if the moon is on one side and the sun is on the other side, then the forces are obviously opposing each other. But if the moon gets over on the other side and happens to be on the same side as the sun, then you know that the two tidal forces are going to add up. So obviously we will get constructive and destructive interference of the tidal forces by the sun and the moon. And that's going to give us very large tides and very small tides based on when they're in phase and when they're out of phase. As you know, moon goes around the Earth and reflect sun's light. So based on what side of the moon we are seeing, we have different phases of the moon, and we have to combine that with the constructive and destructive interference of the tidal forces as well. So that's what we're going to do. Look at the phases of the moon and when the moon and the sun are going to be in phase, when they're out of phase, and what it does to the tides. So that's the tide story. So Earth's rotation and tides end up giving us flood tides, which means the coast gets flooded, so tides are coming in. And then there is the ebb tide when the water moves away from the shore, right? So tidal bulges are fixed relative to the sun's and moon's position, as we saw. We made a simple situation where the Earth was an aquaplanet and moon was on the equatorial plane. So we had two bulges on either side towards the zenith and towards the nadir because the net residual tidal force was maximum on the two sides when you add up from the poles to the equator, right? So tidal bulges are fixed. Earth's rotation, you can think of as if the Earth and the moon are sitting there and the Earth is rotating. So Earth is rotating through the bulges created by the solar and lunar tidal forces. Does that help with anything? Maybe. You can imagine that in an idealized situation, but as we will see soon, once you add land, the tidal bulges become very complicated, but they still make sense. And predicting tides is now a big business. Why? We will relate it to the concept of sea level measurement from the altimeter that we talked about before. If the tides are shallow water waves that are always there every day, and they move the sea level by a lot, and you're trying to measure sea level change, then obviously you have to remove the changes by the tides and other waves and so on. So removing the tides means accurately computing the tides and subtracting from the travel time that the altimeter is measuring. Remember, it's sending a laser, measuring the return time, and there is a reference point on land and so on, the details, but the small changes of few millimeters per year have to be measured accurately, which means we have to just remove these sea level movements because of various waves and tides. There are other corrections as well because the signal is going through the atmosphere, and atmosphere attenuates the signal, and so on and so forth. Satellite business is complicated. We won't get into it too much, but you should be aware that everything you see is being corrected for various factors.